Okay, let's quickly review what have we studied in waves. We have studied that there are basically, as far as medium passing is concerned, there are two type of waves. One wave is called as mechanical wave. The other wave is called as electromagnetic waves. Mechanical waves are those waves which need medium to travel, and electromagnetic waves are those waves which do not need medium to travel. And then as far as shape is concerned, there are two type of wave. One wave is called as transfer waves, and the other wave is called as longitudinal wave. Yamuna, can you please tell me out of these two waves, which one is transfer wave and which one is longitudinal wave? Yamuna? Yes.
The
Ibrahim?
one below is log. I don't know how to say it, and the one above is transversal.
Okay. Not transversal, transverse. In transfer waves, the particle of the medium travel perpendicular to the direction of the motion of the wave. And here, the particle of the medium are actually moving parallel to the direction of the motion of the wave. We have said that already that in these waves, you will have crust and trough, while in these waves, you will have compressions and rarefaction. Then we have example of that wave. The top wave, the light wave is one of the example of that. And longitudinal wave, you have sound wave, example of that. After that, we have also covered electromagnetic radiations or waves, and we have seen the uses of those waves. We have actually gone through electromagnetic spectrum and everything related to that. Now, one more thing, which is very, very important, which we haven't discussed yet, and that is the one I'm talking about here. We didn't see what is a wave show. First of all, there is one formula, which is V is equal to frequency lambda. This is a formula that relates the speed of the wave with frequency and the wavelength. If you want to find out any of these one, you should know at least two variables. If you know any one of these two variables, then very easily you can find the third one, right? Like for example, if you know the velocity of the wave and you also know the frequency of the wave, then very easily you can find the lambda, right? Now, here the next topic is called wavefront. Now, what is meant by wavefront? Now, wavefront is very interesting actually. As we have seen that we can represent wave by different kinds. Like for example, transfer waves are shown like this. And longitudinal waves are shown like particles which are close enough, then particles are far away, then close enough, then far away. Same way, in general, the waves can be shown by the wavefront as well. Now, what is meant by wavefront? Wavefronts are just parallel lines. That's it. Like here. If you see these are lines. And what does it mean? Let me explain you. Wavefronts are useful way of picturing wave from above. Each front is used to represent a single wave. Now, what is wavefront? This is interesting. Wavefront means this line is a wavefront, okay? And the distance between the two line is your lambda. So one complete wavefront is lambda within that. So the image below illustrate how wavefronts are visualized. The arrow shown the direction of the wave in moving and is sometimes called a ray. So this is the wave direction. The space between each wavefront represents the wavelength. When the wave fronts are close together, they represent a wave with a shorter wavelength. Very simple. Like this one have a shorter wavelength, and the other one, this one is having a larger wavelength. So the distance is more, there will be more wavelength. Distance will be shorter. Distance will be shorter means smaller wavelength. When the wave fronts are far apart, this represent a wave with a longer wavelength. All right. I want you to copy this quickly, please, and the diagram as well. This is important. Once you copy, let me know, please. Okay, guys, did you copy? Still working?
Yeah, I'm done.
You're
No,
done?
sir. I just need 1 minute.
Okay, good. Good. And Ashraf, what about you, Betty? Copied? Okay, give me.
So I'm done.
Okay. Now let's proceed further. Let's see what is actually we will finding this. Now check this out. The device which is used to actually measure the wavelength or a frequency is called as a ripple tank. Ripple tank is a device mostly in every school. Okay. Now, where is this is the ripple tank type of thing. Ripple tank is used to find out the wavelength. We got to see shows and everything, and this device is used is actually uh, to find out the wavelength of different type of waves. Okay. Now, once you understand with this one, we have a wave equation here. Let's see. V is equal to frequency lambda. We already established this equation. Now and one more thing, which is very important. In this chapter, we got only two formulas. One is F is equal to 1 upon T, where F is the frequency and T is the time period. It means that frequency is inverse of time period or time period is inverse of frequency. If you know the frequency, you can very easily find out time. If you know the time period, you can very easily find out the frequency of the wave, right? So basically in this chapter, you will have two formulas. One formula is F is equal to 1 upon T and one formula is F is equal to frequency lambda. By using these two formulas, can you solve the question which is given here? A wave in a pond has a speed of 0.15, right, millimeter per second and the time period of 2 seconds. Calculate the frequency of the wave and the wavelength. Can you do that, please?
Sir, can you explain again?
Okay. What my point is, like, for example, if you know the frequency of any wave, you can simply reverse it. You will find the time period of the wave. If you know the time period, you can reverse it and you will find the frequency of the wave. So both are actually reverse of each other. Let's take the example of this question. They say the speed is 0.15 meter per second. So V is equal to 0.15 meter per second, right? Next is time period is given, which is T is equal to 2 seconds. First thing is the frequency. Now we already have established a fact here that time period is actually, if you want to find out the frequency, F is equal to 1 upon T. So it is 1 upon 2, which is equal to 0.5. So frequency of that particular wave will be 0.5 hertz. Now, how to find the wavelength? We know that V is equal to frequency into lambda. So lambda will be equal to V upon F. What is your V? 0.15. What is your frequency? 0.5. What is the answer?
0.3.
0.3. Okay, 0.3 meters. This is your answer. Now let's proceed further. Let's see further what exactly it is, what exactly we have it, because I tried to finish this chapter right now. Okay. So these are the two formulas which will be used to calculate the wavelength and the frequency and everything in this chapter. Now, let's move. See the values. Yeah. Wavelength is 0.3. Right. Done. Okay, now quick test. They are saying test yourself. So let's test ourselves as well. Now, one by one, please let me know. I will ask whoever I'm asking, please tell me the answer. They say following table shows some example of the waves. Which row correctly lists the name of each of the wave type? Sound waves, infrared waves, red light waves. Which column is right? Can you please tell me A, B, C, D? Ibrahim, you.
Sir, aren't sound waves mechanical?
Sound waves are mechanical, but as far as shape is concerned, how does they look like? Because here mechanical is not the option.
Oh yeah. Um,
You have to select from the option which is given.
I think it's either
Tell me one option. That's it. Yumna, you? Yes, Yumna?
Longitudinal
No, no. A, B, C, D. Which one?
B.
so I think it's B.
It's B, because sound waves are longitudinal wave, infrared and red light are the light, so they are both transfer. The best suited option is B. So it's B. Let's do it B. View the answer. Yeah, it's B. We are there. The next is 2. Now, what is the definition of the word amplitude? Read it and tell me which one is the right option. Armina, this is your option now. The number of complete waves that pass point per second, the distance from the peak of one wave to the peak of an adjacent wave, the distance from the equilibrium position of a peak plus the same distance from the trough, the maximum distance from the equilibrium position of any point on the wave. Amplitude. Or Yumna.
D.
It's D, the maximum distance from the equilibrium position of any point on the wave, because amplitude is the maximum position. So D. Let's see. Yeah, it's D. Third one. Now this is interesting actually. What is the name given to the effect that allows the wavefront to reach point X shown on the diagram? Remember that when actually it passes through these small barriers, it basically bends. This is not called refraction. This is not called reflection. This is not called dispersion. This is called diffraction. Whenever light bends or light pass through these small barriers, we call this diffraction. We will be studying this in a minute, but this is diffraction. Check this out. C, diffraction, right? Now the next. Now, which 2 points on the wave are exactly one wavelength apart? Who will tell me this?
So R and S.
RS. Where is RS?
Yeah.
Which option? A, B, C, D.
No, sorry, it'd be B.
It
Q
will
and R.
be Q and S. No, it's not Q and S. It's Q and
It's
R.
Q and R. Q and R.
Why? Because it's there, the point is in phase. Here, the point is in phase. Check it out. It's C. Oh no. They say B is incorrect as Q and R are halfway. So they say C. C is basically, where is C? Q and S, they say. I think so. Yeah, Armina, you're right. It's Q and S. Q and S. Oh, yes, one complete wave. Distance between two consecutive troughs and two consecutive troughs. So this is your, yeah, it's Q and S. Absolutely. Okay, now next. Fifth. What is the unit of wave speed? Wave speed. Remember that.
Second.
Wave speed. The speed of the wave.
It's meters per second.
It's
D.
yeah, it's D. Absolutely right. It's meter per second. You're right. So let's check it out. Absolutely right. It's D. Let's finish this topic and then let's come back to this. Okay. We will see the model question made by actually them as well. But before that, let's quickly see the, all right. Now, this is the wave equation we have done already. Now, transfer waves and longitudinal wave, we already finished with this. We have done that. Direction of the vibrations and everything. What left behind is wave behavior. Now this is interesting. Check it out. Now remember that wave have three behavior. If wave do these three things, it is a wave. Otherwise, it is not considered to be a wave. One is called reflection. We know that wave hit a boundary between two medium and does not pass through, but instead stay in the original medium, or you can say reflect back into the same medium is called as wave. I mean, reflection. We already studied this in a light, so we should know that it is all about light. Angle of incidence must be equal to angle of reflection, right? This is refraction. We already studied about the reflection in the light, that actually it is actually passes into another medium after striking the boundary of the medium. Slow down sometime, and sometime the speed will increase in that. My interesting point is this, that is called diffraction, which the question just came in. When the wave passed through a narrow gap, the wave spread out. This effect is called as diffraction. Now, what does it mean is, if you see these wave fronts, as soon as wave front should pass through a very small narrow, can you see that they start rounding themselves up? So we can say they are actually spreading out. And once they are spreading out, we call this as diffraction, right? One very important thing during that is, check this out. If this gap is actually greater than the wavelength, like it's quite, you can say that if the wavelength is greater than the gap, or you can say gap is very small, they are more round waves. But if the gap is too much, if you just see that, that round will change into sort of a straight lines. And as this gap increases, they will become changing, they are changing into a straight lines. So to have a better spreading out, you need to have as sharp edge as possible, right? So diffraction is what? Spreading out of the wave from the sharp edges, or you can say spreading out of the wave is called as diffraction. Guys, any question in this diffraction? No question? I want you to write it then, please, quickly. And draw the diagram as well. Once you draw that, let me know. Then we will proceed.
Sir, can you show the one with the larger gap again?
Yeah, I will. First you draw that and then I will bring you there. Don't worry. I believe everyone drew this. So let's move on. Now here, please write this down and also draw this one. They're just showing it that if the gap is smaller, then it's more and more rounder. If the gap is bigger, the roundness of the spreading of the wave actually reduces. Okay. It simple says that if the gap is smaller than the wavelength of the wave, then basically, or in other words, when wavelength is greater than the gap, then it's more round after spreading out of the small gap. Or if the wavelength is smaller than the gap size, then the wave after spreading from the gap will be bigger and bigger and bigger and less rounder and less round. Right? So I will read it for you. Diffraction as shown above only generally happens when the gap is smaller than the wavelength of the wave. Now remember that the diagram on the left hand side, which shows the roundness, they are actually called the actual diffraction. As the gap gets bigger, the effect gradually gets lesser pronounced until the case that the gap is very much larger than the wavelength, the wave no longer spread out at all. All right. Just draw that and let me know once you draw that. Ibrahim, did we do radioactivity? Chapter radioactivity?
No, sir, I don't think we did.
Okay. After finishing this waves, we will jump to radioactivity. And then after radioactivity, we will do magnetism and electromagnetism. So once we finish this all, I tell you 60 to 65% of the syllabus is actually covered. Then whatever time we have it, we will do the classic physics, which is kinematics, pressure, all these, okay? And once we've done all of this, we will simply do the past paper practice. But I think so once we finish with this chapter, which we are doing right now, and I think one nuclear physics, we will do topical past paper as well, okay? So get ready for the topical past paper within few days, because radioactivity is a very small topic. You will finish it in a very quick succession of time.